In this question, Maurice is accelerating down. He has an acceleration of 5 meters per second squared. If that is going down, his acceleration will be negative. In this question, we'll also have to draw a free body diagram. In this free body diagram, you have Maurice represented as a dot. You have the force of gravity going down, and you also have a normal force. You'll see that the force of gravity is longer than the normal force in this case because you expect him to get lighter. If you're accelerating down, you expect Maurice to get lighter. Also, when we're talking about normal force and moving down and up, the force measured on the scale is actually the normal force. So what scales measure, if you're sitting down or standing up on a regular surface, is normal force, not the force of gravity. Force of gravity will stay the same if you're on Earth, but normal force is changing. That's why you feel lighter or heavier in this situation. We'll go back to saying that Maurice has a mass of 100 kilograms. We also know that the acceleration due to gravity is 9.81 meters per second squared. And then in this case, the force of gravity is negative. It's pointed down, so we can have a negative 9.81 meters per second squared. This is pretty much all of the givens that we will need. The hard part of this question is using which equations. So I'm going to go ahead and list all of the equations for force that we know. We know that the net force in the y direction is equal to mass times acceleration. This is Newton's second law. We also know that the force of gravity, which is weight, this is weight, is equal to the mass times the acceleration due to gravity. In any diagram with a free body diagram, you'll see that the net force can also be calculated by adding together all the forces. In this case, that's the normal force plus the force of gravity. Now I'm going to solve for the net force using Newton's second law. That's multiplying 100 kilograms times negative 5 meters per second squared, which gives us negative 500 newtons. And the other thing I'll solve for is weight, which is 100 kilograms times negative 9.81 meters per second squared, which gives us negative 981 newtons. If you see here, it's really easy to use Newton's second law from the question and the givens. One of the harder things is to be able to use and solve for the force of gravity. You want to do that because you'll solve and draw a free body diagram first. So when you have a free body diagram, one of the things you want to do is try to figure out what each of these arrows mean. In this case, we know the net force in the y direction is negative 500 newtons. We don't know the normal force yet, which actually tells us how heavy we are in the elevator. And we can plug in for the weight, force of gravity. That's equal to negative 981 newtons. We can solve for the normal force. And by solving for the normal force, we will isolate F of n, which means adding 981 newtons on both sides to give us a normal force of positive 481 newtons. And if you look at this normal force of 481 newtons is less than his normal force of 981 newtons, which is what happens at constant speed or rest. So there you have a proof that you get lighter when you accelerate down.
Hi, YouTube.
Cool.